Hey folks, welcome to my channel Number Pen. So there we have the problem on the screen. A particle moves along a straight line in such a way that after t seconds its distance from the origin is s equal to 2t square plus 3t meters. Find the average velocity between t equals 3 and t equals 6 seconds. Find the instantaneous velocities at t equals 3 and t equals 6 seconds, right? So, what is my velocity, right? My velocity is nothing but rate of change of distance. Okay. So, if my s equals the equation that we've been given is s equals 2t square plus 3t, right? So, this is the equation for the distance. I'm going to solve for 2 first because that's a lot more easier. I know that my ds by dt, which is nothing but a rate of change of distance, is actually my instantaneous velocity at a particular instance, t equals be it 3 seconds or be it 6 seconds, right? So what happens is when I differentiate my s with respect to t, I get the equation for my instantaneous velocity, right? So what happens is 4t plus 3 is nothing but my instantaneous velocity v at any point of time t, right? So now to solve for 2, it's not going to be very tough because what we've been asked to find is instantaneous velocity at v at t equals 3 seconds, and if I can call it v open bracket 3 close bracket, then all that I need to do is substitute t equals 3 into the equation 4t plus 3, which means I'm left with 12 plus 3, which is 15 meters per second. Okay, and then I go to my uh, t equals 6, and let me call it v of 6. What does it call for? It just calls for substitution of t equals 6 in the equation 4t plus 3, and that gives me 24 plus 3, which is equal to 27 meters per second, right? So there we have the answer for part 2. And now I want to draw your attention to part 1, which is my average velocity, right? Now I know that my rate of change of distance is my instantaneous velocity, right? So my average velocity between two instances, right? Here we have distance dependent on time. So my average velocity, which is nothing but between t equals 3 and t equals 6 seconds, is calculated as follows, right? So let me write that down. Average velocity between two instances. So what we've been actually asked to find is between t equals 3 and t equals 6. I know that my velocity increases, right? We know that at t equals 3 we are at 15, and then at t equals 6 we are at 27, right? So that the way to calculate average velocity is s of 6 minus s of 3 divided by 6 minus 3, which is nothing but 3, right? And I know that my s of 6 is nothing but 2 times t square plus 3t, which means I substitute my t equals 6 for s of 6, which means I get 2 times 6 square plus 3 times 6. That's my part 1 of the numerator. And then I also have my s of 3, which is nothing but 2 times 3 square plus 3 times 3, right? And remember that we have a minus sign, and my denominator is nothing but a 3, right? So what I have is 2 times 6 square is nothing but a 72. I have a 72 plus 18 minus of 2 times 3 square, which is again 18 minus 9 divided by 3, right? So what we have is a 63 divided by 3, which is nothing but your 21, right? So that's the answer for 1. So my average velocity between the instants t equals 3 and t equals 6 is 21 meters per second, right? So that's how we go about solving this problem. And I want you to spend a few minutes thinking through another aspect as well. When my v equals 4t plus 3, which is a linear equation, right? Let me highlight that in yellow. You notice that your v of 3 is 15, your v of 6 is 27, right? So your average velocity between the instants t equals 3 and t equals 6 also can be calculated as v of 3 plus v of 6 the whole divided by 2, right? That's nothing but your 15 plus 27 the whole divided by 2, which is nothing but your 21, right? And remember, that's because your v is expressed as a linear equation dependent on the independent variable time, which is t in this particular case, right? But otherwise, if you're being asked to find the average rate of change of a function, say f of x, in the interval a comma b, right? And let's say it's the closed interval a comma b, then your average rate of change of f of x is nothing but f of b minus f of a the whole divided by b minus a. And it so happens that the rate of change of distance is velocity, and therefore you are able to establish the average velocity using this particular expression, right? So that's how we go about solving this problem. I hope you found this content useful. Please do subscribe to my channel and support. Thank you.